Why didn't the tire explode? Every time an airplane lands, something violent happens. Hundreds of tons of aircraft slam into the runway at speeds of more than 250 kilometers per hour. Yet the tires that absorb this impact are completely stationary just moments before touching the ground. In less than a second, they're forced to spin from 0 to full speed. That sudden change creates enormous friction, heat, and mechanical stress. So why don't airplane tires explode every time a jet touches down? The answer is more interesting than you might expect. It isn't just about stronger rubber. In fact, airplane tires are engineered very differently from the tires on cars or trucks. They're designed to handle extreme pressure, sudden acceleration, and enormous loads. And hidden inside them are safety systems that most passengers never even realize exist. To understand why airplane tires survive these brutal landings, we need to take a closer look at one of the most overlooked pieces of engineering in aviation. Let's start with the basic challenge. A fully loaded commercial aircraft can weigh anywhere from 150 to 300 tons when it lands. All of that mass has to be supported by just a handful of wheels. For example, the Boeing 777 uses 12 main landing gear tires. Each of those tires may need to support more than 20 tons of weight during touchdown. But the biggest challenge isn't just supporting weight. It happens in the very first moment the tires touch the runway. Before landing, the wheels are not spinning at all, but the airplane itself is moving forward at more than 250 kilometers per hour. The instant the tire contacts the runway, friction forces the wheel to accelerate from 0 to thousands of rotations per minute almost instantly. That sudden acceleration creates massive forces inside the tire structure, and yet, despite these extreme conditions, tire failures during landing are remarkably rare. The reason comes down to several layers of engineering working together. First, there's the structure of the tire itself. Airplane tires may look simple from the outside, but internally they are extremely sophisticated. Unlike many car tires, which rely mainly on thick rubber, aircraft tires are built from multiple reinforced layers called plies. These plies are made from high-strength materials such as nylon, aramid fibers, similar to Kevlar, and sometimes steel reinforcement. Each layer is wrapped around the tire in alternating directions. This cross-layer structure distributes forces throughout the tire rather than concentrating them in one spot. The result is a tire that is incredibly strong, yet flexible enough to absorb the shock of landing. Even the rubber compound is specially engineered. It must survive intense friction with the runway, extreme temperature changes, and repeated compression during hundreds of landings. But strong materials alone aren't enough. The way the tire behaves during touchdown is just as important. Landing is actually the most violent moment in the tire's life. When the tire hits the runway, two things happen almost instantly. First, the weight of the aircraft compresses the tire. Second, friction with the runway forces the wheel to spin up from 0 to full speed in milliseconds. That rapid acceleration generates a huge amount of heat. In fact, temperatures inside the tire can rise dramatically in just a few seconds. This is why you sometimes see smoke when airplanes land. But contrary to what many people think, that smoke isn't the tire burning. It's usually just the rubber briefly sliding against the runway before the wheel fully synchronizes with the aircraft's speed. Once the wheel reaches full rotation, friction drops sharply and the tire stabilizes. But even then, the tire isn't handling the landing impact alone. It's part of a much larger system designed to manage the enormous forces involved. Airplane tires work together with the aircraft's landing gear, particularly a component called the oleo strut. An oleo strut is a hydraulic shock absorber built into the landing gear. When the aircraft touches down, this shock absorber compresses and absorbs a large portion of the vertical impact energy. Instead of sending the entire force of the landing directly into the tires, the strut spreads that energy over time. This dramatically reduces the stress on the tire itself. Without this system, even the strongest tires would fail far more often. But even with reinforced structures and shock-absorbing landing gear, engineers still had to consider another danger: overheating. This is where one of the most clever safety features in aviation comes into play. Inside many aircraft wheels are small components called fusible plugs. These plugs exist for a very specific reason: to prevent dangerous tire explosions. After landing, aircraft rely on powerful brakes to slow down. These brakes can become extremely hot, sometimes reaching hundreds of degrees Celsius. That heat can transfer from the brake assembly into the wheel and eventually into the tire. If the pressure inside the tire rises too much because of this heat, the tire could potentially explode. To prevent that from happening, fusible plugs are designed to melt at a specific temperature. If the wheel overheats, the plug melts and releases the tire's air pressure in a controlled way. Instead of an explosion, the tire simply deflates safely. It's a small and simple feature, but it represents a powerful concept in engineering: fail-safe design. Of course, even with all this technology, airplane tires aren't indestructible. In fact, one of the biggest misconceptions is that aircraft tires last for years. The reality is quite different. Airplane tires wear out surprisingly quickly. A typical commercial jet tire may only last a few hundred landings before it needs to be replaced. The outer rubber tread gradually wears away due to friction with the runway. But unlike car tires, aircraft tires are designed to be retreaded. Technicians can remove the worn rubber and apply a new tread layer, allowing the tire to be reused several times before it is finally retired. Another common misconception is that airplane tires never fail. Failures can still happen under extreme conditions, but aircraft are designed with redundancy to handle those situations. Large aircraft use many tires so that the landing gear can still function even if one fails. For example, the Airbus A380, the largest passenger aircraft in the world, uses 22 tires to distribute its enormous landing weight. This multi-wheel design ensures the aircraft can still land safely, even if a tire is damaged. So when you put everything together, the reason airplane tires don't explode during landing isn't just one clever invention. It's an entire system of engineering working together. Reinforced multi-layer tire structures, specialized heat-resistant rubber compounds, hydraulic shock absorbers that soften the impact, and hidden safety devices like fusible plugs that prevent dangerous pressure buildup. All of these technologies combine to handle one of the most violent moments in aviation. So the next time you feel that bump when a plane touches down on the runway, remember what just happened beneath you. Those tires just survived one of the most extreme mechanical challenges in modern transportation, and they did it by design. What's interesting is that this kind of design isn't unique to airplane tires. It's part of a much broader pattern in engineering. Systems aren't built to avoid stress. They're built to survive it, control it, and recover from it. And nowhere is that more visible than in the engines of the aircraft itself. Because while the tires only experience these forces for a few seconds during landing, jet engines operate under extreme conditions continuously. Temperatures high enough to weaken metals, rotational speeds measured in thousands of revolutions per minute, and forces that have to remain perfectly balanced to avoid catastrophic failure. But the most surprising part is this: the majority of the thrust that moves an aircraft forward doesn't come from combustion. It comes from something much simpler and much more efficient. Understanding how that works changes the way you see every aircraft in the sky. If you enjoy understanding how machines really work, Consider subscribing for more videos exploring the engineering behind the systems that power our world. Because sometimes the most important technology is the part nobody ever notices.